Alright, so on Bellringer 11, it says for each equation below, write an equivalent equation. Yeah, that's really redundant, below. Notice, these, most of you thought on the Bellringer quiz that these were going to be equivalent. This number here, because these two numbers are the same, that does not prove that they're equivalent equations. Not at all. Just because this says equal 50 and this equals 50, that does not prove that they are equivalent equations. So what we're going to have to do to find out how to write an equivalent equation, we're going to have to solve it. So you're going to find your equal sign, put your finger on the variable, slide it over to the constant. Is that positive or negative 10?
Positive.
So to get rid of it, to throw it away, am I going to use positive or negative 10?
Negative 10.
Good, because we've got to make that 0, because we need to literally get rid of it, throw it out the door. Are these truly opposites?
Yes.
So I'm going to write the green on the right side of my equation. And now, since I have circled my like terms, what am I going to do with them? So I'm going to combine my like terms, and 50 plus negative 10 is 40. Combine my like terms here, and we're combining opposites. So they are going to equal what? 0. So that means we literally threw them out the door. Not literally, figuratively. We threw them out. Bring down my 5x. This, when we put our finger on the variable and slide it over to the coefficient, this means what type of math problem? Is this a multiplication or division problem? Multiplication. And what's the inverse of multiply? So remember that when we have the number with the variable, to get rid of that number, we have to tear it away from the variable by doing the inverse. So we're going to divide everything by 5, and 5 divided by 5 is? 5 divided by 5 is what? 1. So I'm going to write down my 1x equals 8. So to come up with an equivalent equation, we need to write another equation that has 8 as the answer. Not what it's equal to at the beginning, because we have all this work that we need to do before we can solve it. So one way I like to do it is I just like to do this, write down the solution to my equation that I'm going to try to write, and then do something to it. Do something. But to keep the equation balanced, what we do on one side, we have to do it to the other. So if I multiply this by 2, I would have to multiply this by 2, so this would be 2x equals 16. There's an equivalent equation. Because when I solve this, am I going to get x equals 8? Yes or no? What does this mean to do? And what's the opposite of multiply? So if I solve this one-step equation, do I get the same answer? So only way that you can find out if equations are equivalent is if they have the same solution, not the same number in the problem. Another way that you could do this, so if I have x equals 8, Zoe, pick a number. Do you want to add or subtract? So if I subtract 5 from here, I would get 3. So then I'd say, okay, I subtracted 5 there. Equivalent. Do you see that I subtracted 5 here and literally subtracted 5 there? Equivalent equation. Stop the video.